going to factor trinomials today that have a coefficient in front of our x squared term. When we factor these kinds of trinomials, we're going to use a factor sum chart, but it's going to be a little bit different than the factor sum chart we used before. This trinomial right here is factored over here, and what I wanted to do is show you a little pattern that I want you to be aware of, which will help you when it comes to making your factor sum chart. When you use your distributive property on this and you multiply it out, you get these terms on the bottom. And what I want you to see is that this 5x times 5 gives us this 25x here, and this 2 times x gives us 2x. These two terms are really important because if we add those two things together, 25x plus 2x, it gives us our middle term in our problem. So we're still going to be looking for factors that give us a sum of this middle term. Okay, so when we use our factor sum chart, we're still looking for a sum of that middle term. Now the part that's a little bit different is where our factors come from. Okay, if you look at this 25 and this 2, 25 times 2 gives us 50. This 50 is important because that is the product of this last term and this first term in our distributive property. And if we look over here, the first term in our trinomial and the last term in our trinomial, if we multiply those together, we get 50. So we're looking for factors of the product of the first and the last term that add up to the middle term. So let's see how this looks when we're doing a problem. Okay, if I look at this, the first thing I always want to check for is whether or not I have a GCF, which I don't. And then I see that it's a trinomial with a coefficient. So I got to think, okay, I'm going to use a factor sum chart. And what I'm going to look for are factors of this first and last term multiplied together. So factors of 6 that add up to this middle term, which is 5. So I'm looking for factors of 6 that add up to 5. Well, factors of 6 that add up to 5 are going to be 2 times 3. 2 times 3 is 6. 2 plus 3 is 5. So that's the first change in how we do this factor sum chart, is where our factors come from. But the second thing is now our second step. We can't just break this apart into x and x because we have a 2x squared. So when you have a coefficient, your next step is that we have to expand this middle term. And when I say expand that, we're going to break this middle term apart with these two factors, because we know these two factors add up to give me this middle term. So I'm going to break it apart with a 2x and a 3x, because 2x plus 3x gives me 5x. Now the rest of this problem is going to stay the same. This first term will be the same, 2x squared, and this last term will stay the same. The only thing we've done is we've expanded the middle term, and when you look at this, hopefully you'll see, by doing this, we've now created a problem that has 4 terms. Whenever we have 4 terms, we can use grouping. So I'm going to group together my 2x squared plus 2x, and then I'm also going to group together this 3x and 3, and now I can solve this just like a regular grouping problem. If I look at this first group, I'm going to look for a GCF, and the GCF is going to be a 2x, so I'll pull that out, and when I pull out that GCF, I'm going to be left with x plus 1. On the right-hand side, if I look at this, I see that I have a GCF of 3. So I'm going to pull out that GCF of 3, and then when I do that, I'm left with x plus 1. So now to finish off this factoring, my first factor is the things that I had that were the same, this x plus 1. My second factor is made up of the two GCFs, this 2x plus 3. So this is the factored form of 2x squared plus 5x plus 3. Now sometimes when you look at these problems, it's really important for you to think about whether or not you have a GCF. If I look at this problem here, if I just wanted to use a factor sum chart, I'm looking for factors of this times this, which means I'd be looking for factors of negative 432 that add up to negative 6. That's going to be really hard to factor. So before I just jump right in and start factoring, what I want to think about is, does this problem have a GCF? And when I look at this, I can see that yes, in fact, it does have a GCF. It is a GCF of 6. So what I can do is I can take that GCF and pull it outside of this problem to make it a little bit easier for me. So if I take this 6 out of each factor, or out of each term, I'm going to be left with 2x squared minus 1x minus 6. Okay, now that's going to be a much easier problem to factor. And now when I make my factor sum chart, I'm going to be looking for factors of negative 12 that add up to negative 1. So factors of negative 12 that add up to negative 1 are going to be negative 4 and positive 3. Negative 4 times positive 3 is negative 12. Negative 4 plus positive 3 gives me negative 1. Now it's time to take this factor and this factor and break apart this middle term. Now remember, this GCF stays out front. I'm going to break apart this middle term. Instead of negative 1x, I have a negative 4x and a plus 3x. And then everything else in this stays the same. The 2x here, 2x squared here, and this negative 6 are all part of this problem. And what I've done is expand this so that now these things here can be done by grouping. So I need to figure out how can I group this together. Now this GCF is still going to stay as part of my problem. Okay? What I want to do is look at this part here and see how can it be grouped. Well, I can put 2x squared and minus 4x together into one group. And then in the second group, I can do 3x minus 6. And now it's time to finish factoring. This GCF stays put. In this first pair of numbers, I see that I have a GCF of 2x, which is going to leave me with x minus 2. In my second pair of numbers, I see that I have a GCF of 3, and that's going to leave me with x minus 2. And now to finish off this problem, I have to combine all my factors together. My GCF stays put. I've got this x minus 2, which is the same factor. That goes together when I do grouping. And then finally, the last thing I have is I have this 2x here, and I have this 3 right there. And that's my factored form. Now, the last thing you need to worry about is when you have factors that you cannot find the right sum for. In this problem, I'm going to be looking for factors of 14. 2 times 7 give me factors of 14. And I want these factors to add up to negative 11. So if I think about my factors of 14, I have 1 times 14, which gives me a sum of 15. I also have 2 times 7, but that only gives me a sum of 9. If I look carefully, I see the sum there is negative, so that means that I could also have maybe negative 1 and negative 14, because negative times negative gives me a positive, but that sum is actually negative 15. And then when I do my last pair that I can think of, negative 2 times negative 7, that gives me a sum of negative 9. So there is no way for me to find a pair of factors that multiply together to give me positive 14, but also add together to give me negative 11. So in this case, where there are no factors, what you do is you say, this problem is prime. Okay, it does have factors, it's just that they're not whole number factors, and we can't find them this way. So when you're trying to use a factor sum chart, we would just say prime.